Hi everyone, my name is Miguel Davila. I'm a Fusion 360 Catalyst, and today I have part 2 of my Christmas Ornaments in Fusion 360 video series. And today we'll be dealing with the topic of scan data, how to bring it into Fusion 360, how to work with it, what are the different types, and what are some of the advantages of these different design methods. We'll be making this ornament today. It's a little gyroscopic spinner that has a scanned stuffed toy in the middle. So you can easily adapt this design and put anything you want in the middle, and it's just a nice way of integrating something very functional and something very customizable into a single design. So without further ado, let's get started. As in our previous video, we always start with our data set. For this tutorial, I have selected this dataset. It is a scan I made using a old Xbox 360 Connect that I hooked up to my computer, and it was of this stuffed toy they had in my workplace. It's nice and cute, but unfortunately, since I had to mount it high up on an orange chair and a couple of boxes in order to bring it up to the Connect sensor height, I captured a lot of unnecessary detail that I'd like to remove before I bring it into Fusion 360. We'll be using Remake for that, and as you must know, this, just because we see that it's nice and clean and apparently solid, doesn't mean it's quite ready to bring into Fusion yet, even if we don't remove all the extra parts. There could still be a lot of holes, intersections, and just general particles throughout this model that would make it difficult for Fusion to process. What we're going to be doing today is a little different from part 1. We are going to be taking this mesh and turning it into a quad mesh. What is a quad mesh, you must ask? Well, let's switch into Remake real quick, and I'll show you what I mean. Here's our model in Remake, and as you can see, it looks roughly the same, except just without color. So let me switch over the visualization and bring up the wireframe, and you'll notice that it's made of a ton of triangles. What does this mean? Well, much like how objects on your screen are represented by pixels, almost all 3D objects and models are created of polygons. There are two very common formats. One is a triangle mesh, and the other is a quad mesh. As you might be able to tell from their names, a triangle mesh is made up of tons of tiny triangles that connect to each other. These are generally advantageous when you want to capture very fine curvature and detail. However, they are much harder to work with in terms of meshing because you are only able to use tools like, say, a mesh mixer, where you can push, pull, and extrude, and it's not necessarily parametric like we're used to modeling in Fusion. Quads, on the other hand, are, as the name implies, made up of tons of tiny squares. What they lack in the ability to capture detail due to the need for these squares to be uniform in order to complete a solid mesh, they make up for in what they can be converted into. Very often they can be converted into these things called T-splines, which you should be familiar with if you've spent any time in the Sculpt environment in Fusion, as well as Maya or 3ds Max. These modeling tools use these T-splines so that you can push, pull, and do various other transformations very easily onto these shapes. That's what we will be doing today. We are going to be converting this stuffed toy into a quad mesh so that we can bring it into Fusion as a T-spline body and as a solid. So, without further ado, let's get started. We'll use the lasso tool to quickly select out this huge particle. To make things easier on ourselves, we're going to reset the coordinate system very quickly. And you don't have to do this. I just like to do this because I find it makes modeling a lot easier if everything is right side up, like it should be. And you don't have to be precise. Just good enough is fine. So we're going to use the slice and fill tool to quickly remove that box portion. Let's orient ourselves a little bit. And what this will do is it'll cut off that portion of the box there and seal up the bottom of this file. Because what we always want is a solid watertight mesh, meaning there's no holes, particles, or intersections. Hit apply, make sure it fills, and boom, we seem to have a solid mesh. Let's run through the analysis portion, make sure everything's all right. Okay, it looks like no model defects have been detected. And what we'll do now is, under export, we have a bunch of different options: image, video, model. We want to export the model as OBJ quads. You'll notice that under quick export, it already has it. Remake is familiar with this workflow and supports exporting out into OBJ quads for Fusion 360. The maximum right now is 20,000 faces, so we're going to go into advanced, select 20,000, because we want good quality. Because the more faces you have, the more detail you can capture, even if it means a little more processing time. Now I would normally hit export and just let this wait. This can be a very time-intensive process because it has to retopologize and redraw this entire shape with as little error as possible. So what I've done is I've prepared what this will look like once I convert it the first time. So let's open that up. And I renamed it Zach Quads. Always good to rename your files appropriately. Don't save. Excellent. Now you'll see that it looks a little, shall we say, lumpier, a little smoother. And this tends to happen when you retopologize something into quads. It just loses a bit of resolution. Especially since, if you noticed earlier, we had 80,000 faces, and we just decimated that down to a quarter. You'll notice that it seems to still be in triangles. Well, don't worry. If we look at the solid again, and just try and take a peek at the mesh, you'll notice that it generally looks a bit squarish. Remake likes to auto-convert all these square polygons back into triangles for its mesh editing tools. But believe me, it is still a quad mesh. However, because it had to redraw everything, it may have committed some errors. So what we need to do is we need to re-export this out. It's the same process as before, after we detect and analyze any issues. There we go, there's one issue. And oftentimes, especially when you are converting from much larger meshes, there tend to be a higher number of issues like these. So, just like before, remove all, and detect issues again, and just keep doing this until all the problems have been resolved. And once you have that, clear message right there, and you just need to re-export. Select quads again, it's the same number of faces, and it won't touch what it's already fixed. It'll just redraw those portions that you had to repair, and hit export, and there we go. Like I said, this can be a very time-intensive process, so I encourage you to be patient. However, in the interest of time, I have prepared and saved fixed version to show you what it looks like. Notice that it looks virtually the same. That's because Remake didn't touch any of the squares that it already fixed. However, if we run detect issues, we'll notice that it has no issues. Perfect. This is exactly what we want, bringing it into Fusion 360. So let's switch over to Fusion and we'll get started. Okay, so we're here with a new design file in Fusion. So what we want to do is, just like before, insert mesh, find our fixed quad obj, which I've named Zach quads fixed. Name yours whatever you like. You'll notice that this is strange. It has once again turned into triangles. And we can't work with this. So how do we fix it? Well, this is something I ran into a lot previously until I figured out this quick fix. Under Preferences and the Mesh category, you'll find that this is checked. This is called Triangulate Mesh Polygons. Similar to what Remake was doing earlier, Fusion is automatically converting our quads into triangles so that its native mesh editing environment is able to process it as well as edit it. Well, normally this would be good because we want to work with meshes and fuse them together and mix them up. For this purpose, it's actually preventing us from doing that. So we're going to uncheck, hit apply, OK, and re-import the mesh. Notice that now everything looks nice and proper. It's all squares. This is exactly what we want. So I'm just going to hit center because I like things to be nice and centered about the origin. Rotate it so that it's nice and straightforward. And we now have a quad mesh in Fusion. What we need to do now is we need to go into the form environment, because what we're going to do is we need to convert this into a T-spline. So we go into Utilities, Convert, make sure to have the Mesh Body Selection filter on when you do this, otherwise you'll have a hard time selecting like so. Make sure you have Mesh Body selected, and you only have one operation, which is to make a new T-spline. Fine. Hit OK. And this, again, can also take a while, because this is converting it from a single graphic into a Fusion format T-spline body. And while this is working, another advantage of this method is that if you do this at the beginning of your design file, you will end up with a solid, a nice, very smoothed out solid. And this has all the properties of a solid. It has a center of mass. It can be cut. It can be extruded into. It can be made parts of joints and assemblies. This can be fully integrated into your design. And that's one of the benefits of bringing it into a T-spline body before messing around with it. Like in our previous work, or rather I should say, unlike our previous workflow, in order to get any functional components, we not only had to reconvert everything back into a mesh, but all the parts we had designed in the parametric modeling environment, or model, were lost because we had to delete our design history when we converted everything back into meshes for the last step of combination. Here, once we have a nice complete T-spline body, we no longer have to exit the design history. We can just keep it on the entire time. which can be really useful for a lot of designs because having a design history means you can backtrack and edit that much more efficiently. So now that this is finished, you'll notice that it looks pretty good, pretty fixed, but don't let appearances fool you. When you have like 20,000 faces, it's easy to overlook one or two little points that are overlapping and preventing you from turning this back into a solid. So what we're going to do under Utilities, Repair Body, select this T-spline body and just let it recognize any and all points of conflict or error that are preventing you from reconstructing this back into a body. And you see that it found quite a few. Just make sure auto repair is on and it'll do its best to fix all those error points, or error stars rather. And you'll know it's done when OK starts to light up again, and you can just press that. Fantastic, it's finished. And now, as a quick check, make sure that we have successfully converted and fixed all the errors of this mesh. We're going to hit Finish Form, and if it reconstructs back into a solid without any error messages, we know we've done it. It looks like our model has successfully reconstructed back into a solid, and as I mentioned previously, one of the advantages of this method is that if we edit the sculpt feature in the timeline, we have access to all the different sets of tools in the sculpt environment to apply to our scanned data over here, which can be really useful if you want to touch up certain portions or change it up however you wish. And in short, that's how you bring scanned data in OBJ quads, and then T-spline bodies, and finally solids into Fusion 360. And since it's a solid, we can run the center of mass script like we did in part 1, find its center of mass, and move it to the origin so that we can begin sketching that gyroscope that I showed you earlier. And at this point, hope you don't mind, but to speed things along, I'm just going to speed up the video from this point on to show you how I sketched the gyroscope as part of this model. Stay tuned. And there we have it, a completed gyroscopic ornament that's balanced about a mass of the scanned object. Thank you for watching, and I hope you have a nice day.